sometimes different presentations make more sense. So let's take a look here at an animation. Okay, so there's hydrogen, and then over here you see, here we have, there's that one hydrogen electron at its particular energy. And so then if I click to helium, helium has 2 electrons in the 1s, and there they are. Lithium, now we have 3 electrons, 2 in the 1s, and then 1 in the 2s. See a little bit further out, 2s. Then beryllium. Okay, we're adding 2. So again, they're out there still in spherical type orbits. Now we've got, there's boron and out there. Also note, this is nice too, because see how it's showing, these are the line spectrums. Remember how we talked about those? These are the line spectrums for the different elements. So as you click through these, you can see that each element has its own distinctive line spectrum. Okay, and we can keep going. So this is kind of really what we're doing. So there's my P's, and now there, okay, and there's our S, and then another set of P's, and I'm going to click through this a little faster. Okay. Now, look there. See how I'm at the 4th energy level here? But you'll see, especially in the next one, where they have the sublevels labeled, what you should note is that when we get from the 3rd to the 4th, 4th to the 5th, and so forth, with those energy levels, there is some overlap between the higher S sublevel and the lower energy level D sublevel. And so what happens is that this 4S sublevel here is actually at a lower energy than the 3D. So see how once I started getting into this, these, even though they come after 4S, it's actually filling up. These are part of the 3rd energy level here. Okay, so we hit that 4S first, but then it goes to the 3D. But the nice thing about this is you don't have to memorize it. All you have to do is realize how it relates to the position on the periodic table. So we get through the D's, and then now we're back to a 4P. Okay, now let's look at this other line briefly here. And this one is showing, again, more of an orbital notation. Okay, so there's hydrogen, and this is using boxes, and it's also got them kind of in rows, so that you can see the higher the row, the higher the energy level. So here we're filling, and see, again, just like on the other, it always fills in the same order. There's our Hund's rule, 1, 2, 3, and then double up. Okay, again, there's our 3S, 3P with Hund's rule. Going. Now, here we go. See, it's going to the 4S because that's at a slightly lower energy level. Then we hit the 3D. Now, watch what's going to happen here. So this is our normal filling order. But one thing to realize is that there are exceptions to the rules that we have. And one of the exceptions involves the fact that it is more energetically favorable for the atoms to have a full sublevel. And if they can't have a full sublevel, then it's more energetically favorable to have a half-full, an exactly half-full sublevel. So if they can accomplish this, then sometimes the way that they fill their orbitals is going to be a little different. And as you see with the chromium here, what happened? Well, if I'd have gone the normal way, I would have had a full 4s, and then I would have had 4 of the 10 d orbitals filled. Okay, so that's all right, but look at this. Now what do I have? I have a half-filled, exactly half-filled 4s, and an exactly half-filled 3D. So it promoted one of the 4S's up, and it gave it 2 exactly half-filled sublevels. And so that's more energetically favorable. So this is why we see sometimes exceptions to the rule when we're filling. And you'll